As one more example, let's track an aquarium. Aquarium has any number of fish, and each fish has a weight. We don't care what color the fish is, what its name is, what kind of fish it is, just its weight. So for each fish, each individual fish, we can represent it as a number. But we can't represent the whole aquarium with just a number because there's multiple fish in there. And also it can't be a fixed data type of 3 items or 4 items because we said there can be any number of fish. The way to do this in Plait, it turns out, is to write some sort of list data type. So a list of number is going to be either empty or it's going to be a bigger list, which is a list of number with one more number combined with it. Right? And it turns out now that we can represent any number of fish using this list of number data definition. Of course, lists are common and useful, and so list of is actually built in, written something like this. The built-in list of number is something like an empty and a cons case. This is not valid defined type syntax because there's no parentheses around empty here, but it turns out that empty is just a constant for the empty list, whereas the cons constructor for numbers takes a number and some other list of numbers. Using this representation, we can then think about a feed fish function, which takes our aquarium, a list of fish weights, feeds a whole pound of food to every fish, and so we're going to get a list of fatter fish as a result. Okay. Again, our representation step here said we have something that has any number of things in it, so we need to use a list, and we can use the list of data type to represent that. So we don't actually write out this defined type since list of is built in, but I'm writing it here to remind us what it would look like if we did have to write it. Given that then, we're ready to write some example feed fish, examples for feed fish. So it's going to be open paren test, open paren feed fish, and then we have to write down a list of numbers. How do we do that? Well, according to our definition up here, we either write empty or we write cons. And so I end up with examples that look like this. Feed fish on an empty aquarium. If you feed an empty aquarium, you don't suddenly get fish out, so it'll still be an empty aquarium. Whereas if we have an aquarium that has fish of size 1, 2, and 3, 1 pound, 2 pound, and 3 pounds, we feed each fish 1 pound of food. Now our aquarium has fish of 2 pounds, 3 pounds, and 4 pounds. So this way of writing down tests with lists directly follows this defined type sketch up here and helps us understand why we need an empty case and a cons case. We could just as well write the test this way using the list operator. The list form takes any number of things, so if I want an empty list of fish, I can write it that way. And if I write a longer list like this, 1, 2, 3, then I'll get a bigger list as a result. But this way of writing examples is completely equivalent to the other way. This way more directly connects to the data definition. This way is easier to write. It's important to understand the connection between those two ways of writing it. But given those pieces written down, now we can move on to the template step. Feed fish takes a list of number, so that means we're going to have a type case on list of number where we have empty case or a cons case. In the empty case, there's nothing in particular to work with. What about in the cons case? We have this number n, and we have rest lon for the rest of our list of numbers. Is this template complete now? We've written down all the parts. This is just a number. What is this? It is a list of number, which has a data definition. And what function is going to deal with lists of numbers? Well, we've already sketched one out. It's called feedfish. So let's call feedfish on the resulting list of numbers. This is a complete template now. It has all of our cases. In each case, the data we have to work with, a number and a list of numbers, and it suggests a recursive call here because we have a recursive data structure. Now we can finish the body. Let's look at our examples that we had before. As we finish this out, we need to fill in the dot, dot, dots. The empty case is easy. We have an example for that. If you get empty as input, the output is just empty. So we can put empty right there. Let's look now at the cons case. We have a number and another list of numbers. Cons case is here. So 1 right here, 1 corresponds to the number n. That is one individual fish that we want to feed, so we will be adding 1 to that particular number. But then we also have rest of lon. That's the part starting here. So all of this part in blue corresponds to rest of lon in this particular example. Right? Rest of lon stands for cons 2, cons 3 empty. What does feed fish of rest lon produce? Well, if feedfish is doing its job, it's taking the cons2, cons3, and it's producing cons3, cons4. Notice how I'm not trying to think through the recursion. I'm just saying, what is feedfish supposed to do? What is its argument? Okay, what is its result? Good. It's going to be cons3, cons4 empty. So we have plus 1n, that is, we have the number 2 right here. And then we have this part in blue right here, the feedfish rest line. How do we combine these two pieces to get this particular result? Well, we just wrap it in cons. So that's what we do here. We cons plus 1n onto the recursive called feedfish rest of line. For my test step, we run these examples, and we will find that the tests all pass. Looking back at what we just did, we had a definition of list of number where that definition had a self-reference in it. And then we had a function represented by the template at first, and that template had a self-reference in it as a recursive call. So this is what we mean by the implementation of feedfish matches the data definition of a list of number that feedfish works on. Right? And it's going to be important all semester that your function implementations match the data definition. That will help us make sure that our functions work correctly, and it will help other people read your function and understand how it works.